Welcome to The Explainer. So today, we're on a quest. We're hunting for the true answer to a question that seems simple. Does something actually work? Sounds easy enough, right? But as you're about to see, the road to real cause and effect is absolutely riddled with hidden traps.
Okay, let's get right into it with a classic puzzle. Imagine your city launches a brand new job training program. The goal is simple, right? Help people get skills, earn more money. A year goes by, millions of dollars have been spent, and now you need to know, was it worth it?
So you pull the numbers, and at first glance, they look amazing. The folks who went through the training, they're now making $50,000 a year on average. The ones who didn't, they're at $40,000. The conclusion seems like a slam dunk, doesn't it? The program is a $10,000 success. But hang on a second. What if there's a secret villain hiding in these numbers, totally tricking us?
Well, this hidden villain actually has a name, and it's one of the biggest headaches in all of data analysis, mainly because we all fall for it constantly. It's called selection bias.
Just think about it for a second. Who is most likely to sign up for an optional job training program? You know, it's the go-getters, right? The people who are already super motivated, ambitious, and just driven to get ahead. So the big question is, are they earning more because of the training, or would they have earned more anyway just because of that inner fire they already had? That, right there, is selection bias.
This is a great way to picture the problem. That $10,000 difference we saw, it's not pure profit from the program. It's really a mixture of two different things: the true effect of the training, plus this contamination from selection bias. You know, that unfair head start the motivated group had from day one. Our whole mission now is to somehow separate these two.
So how do we actually fight this bias? I mean, is there any way to clean up our data and figure out what the real impact of the program was? Well, thankfully, researchers have a pretty clever strategy for this.
And the core idea here is actually really intuitive. We know the two groups are probably different, so what if we could just statistically control for all the important ways they're different that we can actually see and measure? You know, things like their education level, their age, how much work experience they already have.
But, and this is a huge but, for this whole strategy to work, we have to make a giant, kind of risky assumption. It's called the conditional independence assumption. What it really means that we're basically betting that we've measured all the important stuff that makes the two groups different. The hope is that once we've accounted for things like age and education, the only real difference left to explain the wage gap is the training program itself. It's a big leap of faith.
And then there's rule number 2, overlap. This just means that for our comparisons to even be possible, we need to have people who got the training and people who didn't in every single category we're looking at. I mean, it makes sense, right? We have to be able to compare a 30-year-old high school grad who took the course to another 30-year-old high school grad who didn't. If there's no one to compare them to, we can't do it. No overlap, no comparison.
Okay, so we've got our strategy and our assumptions are in place. But what do we actually do with all this data? Well, this brings us to the really powerful tool that researchers use to put all of this into action.
And that tool is called regression analysis. The best way to think about it is like a super sophisticated statistical machine. We basically pour in all our data, wages, training status, and all those control variables like age and education. Then the regression machine whirs to life and mathematically isolates the impact of every single one of those factors. And this is basically the engine inside that machine. Now, the math can get pretty hairy, but the goal is really simple. The regression takes that $10,000 wage gap and it mathematically subtracts out the part that can be explained by education. Then it subtracts the part explained by age and so on. What's left over, at least in theory, is the pure isolated effect of the training program itself.
And here's the payoff. If, and that is a very big if we believe that huge assumption we made earlier, the one about having measured all the important stuff, then, and only then, can we give a causal interpretation to our result. We can finally say with some confidence that the program caused that wage increase.
So there we go. We found our villain, selection bias. And we have our clever strategy to beat it. It really seems like we've solved the whole mystery. But just when we think we're in the clear, the story takes a dramatic turn.
I mean, it really does feel like we've got a clean, statistically sound answer. We accounted for the differences. We ran the numbers. We isolated the effect. We can trust this, can't we?
And here it is, the million-dollar question that probably keeps researchers tossing and turning at night. We controlled for the observables, the things we could see, the things we could measure. But what if there was some crucial factor that we didn't, or maybe even couldn't, observe?
This right here is the Achilles heel. It's the single biggest weakness of this entire method.
Because when we miss something important, it doesn't just go away. It sneaks back into our results and poisons them with a whole new kind of bias.
It's called omitted variable bias, and it's what happens when there's an unmeasured factor that's secretly pulling all the strings behind the scenes. Remember that personal motivation we talked about earlier? That's not something you can easily put a number on. But what if that's the real reason for everything we're saying?
And here's the key. For an unmeasured factor like motivation to completely mess up our results, it has to pass a two-part test. First, it has to be connected to who gets the training. Check. Motivated people are definitely more likely to sign up. And second, it has to affect wages all by itself. Check. Motivated people probably hustle harder and earn more anyway. Because it does both, it throws our whole result into question.
Okay, so let's bring this all home. What does this deep dive into the statistical weeds really mean for you the next time you see some headline that says, "New program boosts income," or "Study proves X causes Y"?
It means you now have an awesome new toolkit for thinking critically. The next time you see a study, don't just jump to the conclusion. Ask yourself these three simple questions. 1. How are the two groups being compared different from the start? 2. What things did the researchers try to control for? And 3, the most important one, what invisible factors might they have missed? Things like raw talent or family support or just plain old motivation.
Because figuring out what truly causes something is just incredibly difficult. And knowing about this hidden trap of selection bias and omitted variables, well, that's the first and most powerful step you can take toward becoming a much smarter consumer of information and getting that much closer to the real truth.